Hi everyone, welcome to all of you guys. Kindly confirm once whether am I audible to you or not. Everyone please confirm. Okay. Hi Tamilong. Please share the topic as well that we were discussing in the last class. Hi, good afternoon Shillong. What was the topic we were discussing in the last class? Bronsted-Lowry concept has been covered. Okay. Anyone has got any doubt, any query, any question that you want to ask me? Okay. So let's continue. I guess so that Bronsted-Lowry concept has been finished totally. Now, let's check out how we can predict the direction of equilibrium in case of acids. Okay. Or not acids, we can simply say the acid-base reactions because we are discussing about the acid-base reactions. Okay. So first of all, copy this one, guys. Make a note of it. That acid-base reaction always proceeds from strong to weak direction. Means strong acid to strong acid to weak acid, or you can say that strong base to weak base. Remember one thing, you have to just pick any out of acid or base, you have to pick any one or of these two. Okay. You can either choose acid or base. Okay. You won't do that, you are comparing the acid and the base. Okay. This comparison based on either acid or base. Okay. Let me take an example so it will be little bit more clear to you. For example, Na2CO3 plus H2SO4 is giving you Na2SO4 plus H2CO3. Okay. Now here I am choosing H2SO4, which is an acid. So on the right hand side as well, I'll choose the acid. So you can pick H2CO3. Okay, which is an acid. If I ask you out of these two, which one is stronger and which one is weak, so you can simply check out that H2SO4 is a strong acid and H2CO3 is a weak acid. Note says that it will always proceed from a strong part to the weak part. Okay, so you can check out here that the strong to weak means from left to right. From left to right. It means that direction will be what? Forward. Okay. Copy and confirm that. Is it clear to everyone? Please confirm, everyone. Is it clear? Please copy. Itanagar, Tamilong, Senapati, guys, are you there? Okay. Now I'm giving you questions. Guys, you have to predict the direction of equilibrium. Predict direction of equilibrium for the following reaction. HCONA with CS3COH number 2 Cl minus plus H2O is giving you HCl plus OH minus. Do this question, guys. You have to consider either acid or base in the chemical reaction. After attempting that, just confirm once that you have done with that. Okay. Okay, so guys, let's discuss this one. See, CS3COH is an acid, whereas HCOH is also an acid. So this is your weak acid. This is your strong acid. Okay. So you can check out in question number 1, strong acid is present on the product side and weak acid on the reactant side. So actually, this one will proceed from product to reactant side. That's why this one will become the backward. Okay. Whereas in this case, first of all, you need to identify which one is acid and which one is base. Okay. So if you check out that water is proton donor here, so this one will behave as an acid. And here on the right hand side, you can check out that HCl is already an acid. Okay. So water on comparison with HCl is found to be weaker acid. Okay. So again, the direction would become backward. In the last part, they are given bases. Okay. So I'll choose the bases. Okay. This is your weak base. This is your strong base. Okay. So here also the direction would be backward. How many of you has got all 3 correct answers? And if anyone there who has got confusion in any of the question, you can please ask me. Shillong, no one has got the wrong answer. Wow. Okay. You're confused with the 3. Okay, let me check it. Okay. Okay. Let me explain the question number 3. See, in the question number 3, first of all, let's check out the reactant side. So this is nothing but the Bronsted-Lowry concept. You can check out that here Na plus can take out only OH minus. Okay. Here Na plus can take only OH minus over there. Okay. And water can be dissociated over there to give what? H plus and OH minus. Okay. Now the problem is, one second. Now the problem is, if I check out the Bronsted-Lowry concept, and according to that, it is quite difficult to explain that how will I identify the acid or the base. Okay. So in such type of questions over there, I'll suggest just go from the predicted side. Okay. Go from the predicted side. See, here you can check out NaOH, which is what? A base. Okay. So obviously, if it is a base, then the H plus will definitely what? An acid. Okay. Now, on the basis of this one, you need to make the pairs over there. Okay. You need to make the pairs over there. Okay. This is actually this is what? Your Arrhenius concept, not the Bronsted-Lowry concept. Okay. So, Bronsted-Lowry can't define it very well over there. Okay. Now, you need to pair up these two terms. Okay. And after pairing, you need to identify here which one will be the acidic pair and which one will become the basic pair over there. Okay. So, we can say that the base forms what? Conjugate acid, and the acid forms what? Conjugate base. Okay. So, this one is also what? Base part, because this is been related with what? H plus over there. Okay. Now, as you can see, you have figured out two bases. See, you can't compare the acidic strengths of the Na plus and the Na plus and the H plus. Okay. Because there you have got only H plus over there, so it is not possible to determine their strengths over there. So I'll go with the bases. Okay. So you can check out that the H2 and NaOH both are the bases. Now on the basis of that, you have to just check out that which one is a stronger part and which one is a weaker part. Okay. And I'm sure you know that H2O on comparison is found to be weaker base, and NaOH is found to be what? Stronger base. Okay. So after identifying the base, just check out your direction. Okay. Got it, guys? See, these are quite good questions. Okay. So you can learn lots of concept by solving the questions. Okay. Now got it? Itanagar, Temelong. Guys, have you got that? If still anyone has got any doubt, you can please ask me. I can take another example to just explain this such type of questions. But I'll suggest just don't just look at the question reactant part. Also check the predicted part. If you are not much clear with the reactant side, because reactant can't decide here that which one will be the acid and which one will be the base. Okay. Okay, so let's move on. Next is, guys, please mark your attendance. Everyone, every center, please mark your attendance. amphiprotic substance. Okay, amphiprotic means, guys, those substances which can accept as H plus as well as can donate H plus. Okay, means they are having the capability of accepting as well as donating the H plus ions are known as what? Amphiprotic substances. Okay, so first of all, let's write down its definition. That substance which can donate as well as accept H plus are known as what? Amphiprotic substance. So if you take an example of water, we know that water can give H plus, it will form OH minus, and if it adds H plus, it can form what? H3O positive. So ultimately water is what? Amphiprotic substance. Okay. I think so you have already heard the word amphoteric. Okay. Amphoteric means those substances which can act as acid as well as base. Okay. So in the same manner, there is another word which is what? Amphiprotic substance. Okay. So amphiprotic nothing but the species which will donate as well as accept the H plus ions. Okay. So just copy this one. And let's take another example. See, I say H3PO4. Okay, so H3PO4 can lose proton because it is an acid. It will form H2PO4 minus. This one can also lose proton to give H4 2 minus. Now, this one can also lose proton to give this one. Now the question is, in the given chemical reaction which is being started from H3PO4 and ended up at PO4 3 minus, you need to identify the acid, base and the what is this? Amphiprotic substance. Okay. In the given chemical reaction, you need to identify acid, base and amphiprotic species. Just attempt that and then we'll discuss about it. After doing that, just confirm once. Okay, so let's start. See, H3PO4 has ability to donate H plus only. Okay, so it can donate only. So this is simply the acid. But check out this one. Even just because it has got the negative ion over there, it has a capability of accepting H plus as well. Okay, here it is donating as well. Or you can check it out as well, that H2PO4 minus after donating the H plus forming the HPO4 2 minus. Okay, so it is definitely an acid, but yes, just because of the negative charge, it can accept H plus as well. Okay, so this is amphiprotic. Similarly, the same thing with this one. This is also what? Amphiprotic. But PO4 3 minus do not have any proton over there for the donation. That's why it cannot donate any H plus ions over there. But yes, it has ability to accept the H plus. Okay. So we can say this one will be what? Conjugate base. Got it? Any doubt about it? Okay. Let me tell you. First of all, copy this one. Copy this one, then I'll tell you. Okay. Check out. Now look at this. S3PO4 is giving an H plus, forming this one. See, S3PO4 cannot accept any proton because it do not have any charges over there. Phosphorus do not have any of the other properties by which it helps in the acceptance of the protons. Okay, so it can donate only the H plus. That's why it is an acid. Now check out this one. If I react this one with a proton, it will get back to what? S3PO4. Okay. See, if this condition satisfies, so H2PO4 minus is accepting the H plus. That's why it is a what? Base. But it can also donate the H plus and form this ion. Okay. So what actually H2PO4 minus can do, that it can donate H plus, therefore it is an acid. Now, in the case it can accept H plus as well, therefore it is a base. So this one, H2PO4 minus, has ability to accept as well as donate H plus ions over there. That's why we can say it is an amphiprotic substance, just because of its ability to accept as well as donating H plus. Okay. Now, if you check out HPO4 2 minus, see, this one can accept H plus, and after accepting, it can form this one. And yes, this one can donate H plus, and after donation, this one will get converted into what? This one. Okay. Now check out this one. This is also doing the same. Again, it has ability of accepting as well as donating. That's why again this is what? Amphiprotic. But once this one is formed, I mean to say that, can you see any H plus over there in PO4 3 minus? Is there any H plus over there? Yes. If there is no H plus over there, so it means that it cannot donate any H plus. So if it cannot donate any H plus, it means it can't behave as an acid. But yes, it can accept H plus. And after accepting, it will be look like this one. So this particular process, this particular process will be what? Base. That's why we are saying that PO4 3 minus can only be behaves as a base, S3PO4 just as an acid, whereas the middle part, H2PO4 minus and HPO4 2 minus, can be amphiprotic substance. Now clear? Now clear to everyone? Or still got some doubt? Just correlate this one with the H2O. That H2O can accept as well as donate H plus. Okay? Okay. Question is, write conjugate acid and conjugate base of the following. First is HS minus, second is HCO3 minus, and third H2PO3 minus. Attempt. Just confirm after attempting that. Done, guys? Okay, so let's write the answer. Substance, conjugate acid, conjugate base. HS minus, H3O minus, H2PO3 minus, H2S, S2 minus, H2CO3, CO3 2 minus, HPO3 2 minus, and this is H3PO3 and this is HPO3 2 minus. How many of you has got all correct answers? Kindly confirm once. Camera is little bit slow, means internet speed is little bit slow, so I cannot see your actions, Shillong. So you need to type it. Tamelong and then Itanagar and Senapati, guys, how many of you has got the correct answers? And out of HS minus, HCO3 minus and H2PO3 minus, identify the amphiprotic substances. Okay, good. Eliza, Nitish, Ernie, Priyanka, Emika, Lima, Vanti. Very good. I think there are 7, not 5. Okay. Okay. Tell me, Itanagar, Tamelong and Senapati, guys, are you there? Have you got the concept? Guys, identify amphiprotic substance in HS minus, HCO3 minus, and H2PO3 minus? Tell me the answer. You can simply say 1, 2, 3. Need not to type the substances. Okay, very good, Shillong. Yes, all are amphiprotic because all can have conjugate acid and conjugate base, means all has ability to accept as well as donate H plus ions. Okay, so they all will be the amphiprotic. Okay, so that's all about your Bronsted-Lowry concept. Now the last concept, which is Lewis concept. Lewis concept was totally dependent on the electron pairs. Okay, it measures the acidic and basic properties on the basis of substance which can accept or donate the lone pair of electrons. See, till now we were dealing with the H plus ions. Now H plus won't be further part of this section. Now now H plus will be replaced by what? Electron pairs. Okay. So Lewis concept says that acids are those substances which can accept lone pair electrons. Okay, where bases would be those substances which can donate lone pair electrons. Okay. If we check out the acids, in acids generally we can identify the cations like Cl plus, CH3 plus, we can say Br plus, etc. Okay, they all are what? They all have the tendency to accept the H plus ions. They all have tendency to accept the electron pairs. That's why they are the acids. Okay. Acids are simply what? Electron deficient species. You can say that. Yes, you can even note down this one as well. But where would you copy it? Wait. Even this one is very important point, that they are electron deficient species. Okay. Now, for example, cations like Cl plus, Br plus, CH3 plus, etc. Many more. Okay. Some neutral species are also there, like SnCl4, FeCl3, AlCl3, FeBr3, BF3, etc. Okay, they all have central atom vacant orbital. So those vacant orbitals can accommodate the electron pairs. That's why they are also known as the acids. Copy and then confirm. And you can mention here having vacant orbital. Okay, that vacant orbital can accommodate the extra electrons. That's why they are the acids. Copy and then confirm. Okay, so let's move on. If anyone has any question, you can please ask. Bases. These are electron rich species. For example, all anions. All anions will be what? Lewis bases. Okay. Copy. Just confirm after copying that. Shillong copied now. Okay, let's move on. All anions. Welcome, dear. For example, OH minus, R minus, we can say O minus, etc. Means whatever anion you find over there, they will be the bases. Okay. Other than that, some neutral species are also there, like ROH. Just because they contains the lone pairs, that's why they behaves as a base, like NH2, R2NH, etc. Means where you can find the lone pair of electrons, they will become the Lewis bases. Okay. Copy. And any question? Etanagar and Senapati, are you there? Okay. So let's move on. So that's all about, guys, the theories related to the acids and base concepts. Now let's move on to the section where we will have the equilibrium. Okay. So in this one, first basic law about which you have already learned, but here it's intro here. Ostwald's dilution law. Okay. It is applicable to weak electrolytes only. Okay. Let's check out. Let's say suppose we have got AB. It is giving you A plus aqueous and B minus aqueous. Okay. Initially concentration was C, okay, and after some time when equilibrium has established over there, let's say suppose C alpha part has been covered here, means has been converted into the product, okay. Now, what about AB? The left part would be C minus C alpha, okay. So, we can identify Ki. Ki is what? Ionization constant. I stands for what? Ionization. We can say this is the concentration of A plus and concentration of B minus upon AB. Just put these values and you will get what? C alpha square upon C minus C alpha. When you solve that, you will get what? C alpha square upon 1 minus alpha. Okay? 1 second. Now, what can I conclude? That Ki would be equals to what? C alpha square upon 1 minus alpha. Okay. This is the first basic formula. And one more important thing, guys, we have learned that alpha is very, very negligible with respect to 1. Okay. That alpha is very, very less than 1. So, what can I say? That 1 minus alpha should be nearly equal to what? 1. Okay. So, if I check out this, I can get C alpha square only. Okay. And here I can calculate the value of alpha, which is under the root Ki upon C. This is the required formula. Okay. Here you can get the value of alpha. Okay. Any doubt about it? Clear to everyone? Just copy it, guys. Okay, copy this one. Copy and then confirm. Okay. Do not copy anything, just look at the screen. Now, core concepts are going to begin right now. Okay. So, just look at the screen. First of all, understand the meaning of that one, and after that, you can copy that. And for next few minutes, I need one person on the system, so he or she can reply with the concern of all students. Okay. So the next topic is common ion effect. Its applications would be used later on, but the concept we are going to discuss right now. Okay. First of all, a common ion will always be observed when in the chemical reactions, one ion is common over there. One ion common means that for the different substances, suppose I'm mixing the two different substances, okay, and on mixing these two substances, I found that the substances has the one common ion over there. We can observe the common ion effect over there, okay. So first of all, let's understand its meaning, okay. See, let's say suppose I have AB, and this can convert into A plus and B minus, okay. I have added AB, sorry, not AB, I have added AC here. Means in a container, I was having the AB mixture. AB was already in the equilibrium state, and which has dissociated into A plus and B minus, and there is already established equilibrium. Now I have added an electrolyte into that solution, and that electrolyte dissociated to give you A plus and C minus, okay. Now you can check out, there was already an equation over there, we can say a reaction over there, where equilibrium was present already there. But I have added another electrolyte, and after adding that electrolyte, I found that one of the ion which was already present in the first chemical reaction is now introduced over there, okay. So obviously, if I ask you, again guys, do not copy this, I need to fill up these gaps, okay. Now if I ask you about the concentration of A plus, obviously it is increasing over there, because A was already there, you have added an electrolyte, and from that electrolyte you are also getting the A. So we can say that A is increasing over there. My question is, what will be the effect on concentration of B with respect to A? Whether it would be increase or decrease? Are you getting my question? I'm just asking in relation with the A, what should be the concentration of B? Whether it should be increased or decreased? Just compare A and B. Are you getting my question? If you're not getting my question, you can please point out over there. Okay. Do I need to repeat the question? Please confirm once. Yes, very good. It will decrease. See, why we are saying the decrease. Let's say suppose initial concentration was C, this was 0, this is C alpha, this is C alpha, this is C minus C alpha. Okay. You are saying the A is increased. Initially the concentration of A and B were equal. You can check out, this is both are the C alpha. Okay. Now something is already being added over there. So obviously A is slightly been increased. So in relation with the A, B we can say D is decreasing. Okay, it is just a comparison basis. With respect to A, it is decreasing. Okay. Otherwise, it is actually constant. Remember one thing, that concentration of B is actually constant. It is neither increasing nor decreasing, but in reference to A, it is decreasing because A is increasing over there. Okay. So, one more thing. I have a question for you. If concentration of product is increasing, you are saying A is increasing. It means that concentration of product is increasing. What should be the direction of equilibrium? It should be forward or backward? I am saying concentration of product is increased. What should be the direction of equilibrium? Wow. How is it possible if concentration of product is increasing, the direction would be forward? It should be backward. Check out the Lee-Chatelier's principle. And the first case was effect of concentration, where we have copied that on increasing the concentration of reactant or decreasing product favors the forward. For the reverse, it would be backward. I hope so, no doubt about it. This is clear to everyone. Okay. So we can say, yes, Shillong. Do you have any query? Okay. Product is increasing, so direction would be backward. So actually what I would like to say that whenever common ion effect is observed, direction will always be backward. Make a note of it, that even I will write it, that whenever common ion effect is observed, direction of equilibrium will always be backward, because in case of common ion effect, the common ion will always be on the product side. It can never be in the reactant side. Okay, that's why it will favors the backward reaction. Okay. Now the second part, I can say that B is decreasing. Okay. So what can I conclude? That if concentration of B is decreasing, and concentration of B, we have just written C alpha, it means that C alpha should also be decreased. It means that the extent of dissociation will also be decreased over there. Okay, I hope so it is clear to everyone. Now, what can I say? That common ion effect operates only on weak electrolyte. Next, concentration of common ion increases, alpha will decrease. Okay, we can simply say that common ion increases, alpha will decrease. It favors backward direction. First, my question is to you guys. Are you clear with the concept? Are you clear with the concept? Any doubt or any small point which is not clear or you want to ask me? Please let me know right now. Okay. So now I'll write its definition. If it is clear to everyone, now I'll write its definition. That now you can start copying that. It is applicable when minimum 2 electrolytes having 1 ion common present in the solution. Okay. For example, CH3COH plus HCl. Okay. Here you can identify that H is common. Okay. We will use its application later on. Just copy this one, guys. And after copying this page, let me, please confirm me. Tamelong, Eton, guys, is this clear to you? If you have any doubt, you are most welcome. Copy this one as well. This one as well. After copying that, everyone has to confirm once. Okay, so let's move on. Next important part, pH and pOH. Can anyone please tell me what is the meaning of pH and the pOH? Okay, let me start. pH is simply power of H, and this is your power of OH. Yep. Your potential hydrogen as well. Okay. Potential hydrogen as well. I have simplified that one. Okay. If numerically we discuss that, how you can discuss, or we can say express the pH, so we can simply say that pH is nothing but it is the negative of logarithm of concentration of H plus ions. Whereas if we would like to define the pOH, we can say that it is the negative of logarithm of concentration of OH minus ions. Okay. This is how you can define it in mathematically. Okay, so just copy its definition. You can copy with me. It is concentration of H plus ion is expressed in terms of negative power of 10 and numerical value of that negative power is known as pH. Okay, just copy this one. Okay, let's check out that concentration of H plus can be written as 10 to the power minus x. Okay, where x is equals to what? pH. So what can I say? Some mathematical section is there, guys, so you just check out this one, and if it is not clear to you, you can ask me. See what I'm saying, that numerically H plus is equals to what? 10 to the power minus x. That x is nothing but equivalent to the pH. So I can say H plus is equals to what? 10 to the power minus pH. Now if you solve that mathematically, and after solving, you will get that pH is nothing but equals to what? Minus log of H plus. About this definition we were discussing, that pH is nothing but minus of log of H plus ions, and which is obtained from this one. Okay, this is the mathematical definition. And you can remember one thing, guys, pH is inversely proportional to concentration of H plus ions. Quite important. You can directly answer few of the questions. Okay. And yes, in the examinations you might get the logarithm values. Most of you will get the logarithm values. And other than that, I'll suggest you to remember few logarithm values over there. Okay, like log 2, log 3, log 5, then log 7. And with the help of these, you can find the other values too. Okay. Do you know how to check out the log table? And do you know the basics of the logs? That how we can determine the logs? Please tell me quickly. If not, then I'm going to discuss the basics of the log. Okay. Fine. I'll discuss the logs. Just copy this and intimate once. It's okay, Shillong. I'll discuss how to check out the logs. Okay, because log is very, very useful in case of electrochemistry, chemical kinetics, and yes, here it is most important. Just copy and then confirm. Done? Okay. Can we take a break of 5 minutes, or would you like to continue? It would be your choice. Okay. So I'll see you in the 5 minutes. Hi guys, welcome back. Please confirm that is my voice is audible to you? Are you getting it? Everyone, please. Okay. So guys, let's begin with the logs. There are few properties that you need to remember. Quite easy properties. Okay. And remember, I won't discuss the log again, means in the chapter of electrochemistry, thermodynamics, and then chemical kinetics. There as well you will find out the logs. Okay. So just learn these logs right now, quite important as well. Okay. So let's start with the logs. Okay. You won't get any straightforward question on the based on the log. They will ultimately used in a formula. And to answer that question, you need to solve the logs. Okay. So first of all, write its basic property, basic properties like log m into n is log m plus log n. Log m to the power x is equals to what? X log m means power comes before the log. Log m upon n is equals to log m minus log n. Log 10 to the power x is equals to x. Okay. Plus minus. Might be it has plus power or minus power. Whatever it is, log 1 is 0. Very important. Log 0, undefined. Copy, please. Copy and then confirm. You guys need to confirm it. After copying that. Okay. Other than that, remember these values. Log 2 is 0.301 and you can simply remember 0.3. Okay. Log 3 is 0.4771 and for the numericals you can remember 0.48. Log 5 is 0.6990 and you can simply say it is nothing but 0.7. Okay. Log 7 is 0.85. This is not also the exact value 0.85. Okay, but I have written the approximated value over there. If you know this value, then you can calculate any value of the x except the prime numbers. Prime numbers which are not divisible with the any number except itself. Okay. Like we can't get the value of 11, 13, then 17, 19. These are the prime numbers. We can't get the values of those numbers, but yes, they will be really helpful while solving the other numbers. Let me tell you how. Now just look at the screen, guys. I am taking few examples. Let's say suppose you need to calculate the value of 6. Okay. So first of all, try to break the 6 into much more simpler fractions. I know I can write 6 into 2 into 3. Sorry, 6 as a 2 into 3. And I know that there is one of the properties of the log m into n which says that this should be log 2 plus log 3. So I know the value of log 2 which is 0.3 and log 3 is 0.48. Now you can solve it and you will get what? 0.78. Got it? How you will get the value? Got it? See, if I am too fast while solving such questions, you can please tell me once. Okay. And confirm, are you clear with the first question? Are you clear with the first question? Okay. Remember, in the question of the pH, you need to solve that. So learn it. Okay, let's move on to the next question. Please do not copy anything, just look at the screen and understand that how I'm calculating the logs. Okay. Check out the question number 2. If I say x is equals to log 125 upon 15. Okay. So first of all, guys, try to break it into the simpler numbers. Okay. So I can write it as a 25 by 3. Okay. I can write it as a what? 25 by 3. How? I have divided both the numbers with the 5. Okay. And after that, I'll get this number. Now you can check out, this is the property of the log m upon n. So I can write it log 25 minus log 3. Now, I have told you the value of log 3, but I haven't told you that what is the value of 25. So here, I need to break the 25 as well, and I can say that 25 can be written as what? 5 to the power 2. Means 5 square is nothing but what? 25. Sorry. Might be it is looking a little bit complex to you initially, but guys, there is no other choice. I am just telling you that how you can simplify this one. Try to simplify those numbers. That's it. If you are trying, if you are able to simplify that numbers, you will definitely get the answer. And this is one of the properties that power will come before the log. And finally, this is the simplest number. So log 5 is nothing but 0.7 minus 0.48. Just solve that. This is 1.4 minus 0.48. So I guess so you can solve this, and after solving you will get what? 0.98. Will it be 0.98? No, not 0.98. 0.92. Yes, it will be what? 0.92. I hope so it is clear to everyone. Guys, have you got that? I know this is little bit lengthier question, but you can do this. Clear, guys? Shillong, Tamelong, Itanagar, Senapati, guys, is it clear to everyone? If not, it is clear, you can just tell me. Do not just focus on the copying. Just focus on the questions, that how I am solving it. Okay. Now, next part. This is log 200. Now the important point, guys, look at this one. Look at this one. By the use of the log table, the number should be present in this format. Log A point B C. Means after the first digit, non-zero digit, there must be a decimal. This is what? Non-zero digit. Means this is the format actually. And you can check out that every number was in this format. Like this is 2.00, this is 3.00, this is 5.00, and this is what? 7.00. Okay. This is just an additional information. Means that is quite helpful for you, that you have to remember. Now check out this one. This is 200. I know that we don't know how to check out the 200, so I can simply write it 2 into 10 to the power 2. So on splitting it, this is log 2 plus log 10 to the power 2. So you can say log 2 is 0.3 and this is nothing but 2. Answer would be 2.3. Got it? Copy and then confirm. After that, I am giving you a few questions. You need to tell me the answer. And yes, please bring the log table as well in the next class. I'll tell you that how to check out the log table as well. Okay. This is just a trick ultimately, where you can get the fastest solution in the examinations. Okay. Okay, so let's move on. I'm giving you a few questions, guys. You have to tell me the answer. X is, and yes, along with the log table, bring the anti-log table as well. See, I have to tell you anti-log as well, but for the anti-log, I need the anti-log table, okay? Because there is those general terms over there, okay? So I need anti-log table. So just bring the log and anti-log table in the next class, okay? So X is equals to 625. Tell me the answers, guys. Solve these questions. Tell me the answers. confirm after completion of these questions. Everyone, Shillong, Itanagar, Senapati, Tamenglong. Do this one as well. Log 343. One is 2.8. Okay. Don't know. Okay. Okay. Let's see. Do this one as well. Tamenglong, Itanagar, Senapati. Guys, have you got the answer? Okay, so let's begin, guys. Let's check out. Or start with the question number 1. X was log 625. So this is nothing but 5 to the power 4. Means if I multiply consecutively 4 times, I'll get the 625. See? 5 into 5, 25. 25 5s are 125. 5s are 625. So this is nothing but 5 to the power 4. Okay? So what can we do? 4 will become before the log 5. Value of log 5, what we have written? This is 0.7. So 4 into 5, sorry, 0.7. So this is 2.8. So what was the first answer? Very good. You have absolutely correct answer. Second is x is equals to log 333 upon 111. It is nothing but log 3. And log 3 is what? 0.48. Absolutely right. Second answer. Number 3. Number 3 is 500 by 2. 500 by 2 is nothing but what? 250. And 250 can be splitted to form 25 into 10, and which is nothing but log 5 to the power 2 plus log 10. Okay? So log 5 to the power 2 is nothing but log 2 into 0.7 plus 1 is equals to what? 2.4. Very good. Number 4. 425 by 17. This is nothing but 25. So this is what? Log 5 to the power 2. This is what? 2 log 5, 2 into 0.7, which is 1.4. Last. 343. 343 is actually the cube of 7. So this is 3 log 3, 3 log 7. Log 7 is 0.85, so you can solve it. This one will be the answer. You can please copy those who haven't got the correct answer. You can start copying from here. And please confirm how many of you has got all correct answers. How many of you has got all correct answers? And how many of you are still having some doubt? If yes, you can please ask me. And please bring the log table in the next class, because I have to tell you anti-log as well. Okay. And yes, how to check out the log table. Number 2. Divide 333 by 111. See, this is 3 actually. Okay. It's okay, Tamalong. Please copy. Or Shillong, are you clear? See. Is 333, na? So just divide it. You will get it. Okay? Yes, it is. Shillong, how many students has got the correct answers? Number of students. Please copy this one as well. Tamalong and Itanagar. Write the number of students who has got the correct answers. Okay, very good. And how many attempted? I mean, how many students has attempted the questions? This is for Shillong. Very good. And I guess so even half of the students haven't attempted the questions. Copy and then confirm, guys. Okay, Itanagar. Okay. So guys, let's wind up today's session. Okay. In next class, I'll discuss the pH. Okay. And before that, please make sure that you will bring the log table in the next class, log table as well as anti-log table. Okay. I'll tell you how to check out the log and anti-log. Okay. So till then, take care. Bye bye. Thank you so much. See you next time.